A human hair cannot slip between the stones of some ancient walls. This is the mystery of the world's perfectly carved monoliths, a global puzzle where ancient builders achieved a precision that still baffles modern science. By the end of this journey, you will understand the incredible lost knowledge that might explain these impossible structures. How did cultures across the world, from the high Andes to the deserts of Egypt, carve and move 100-ton stones with laser-like accuracy without the tools we would consider essential today? What does our struggle to replicate their work say about our own understanding of history? The air is thin and cold before sunrise at Saqqara. Your fingers would trace the seams between these colossal limestone blocks and find no seam at all. This is the definition of perfection in stone, a standard so high it defies simple explanation. A perfectly carved monolith meets 3 impossible criteria. Its joints are seamless, allowing neither blade nor hair to penetrate. Its geometry is flawless, with stones cut at multiple complex angles to interlock in 3 dimensions. And its surface is often polished to a smooth, almost glass-like finish, all achieved without the power tools or laser guides we have today. Archaeologist Jean-Pierre Protzen spent years studying these walls, and he concluded that the methods used to shape such stones remain a mystery. The builders employed techniques we simply cannot replicate with the primitive tools we attribute to them. Consider the multi-angled cuts. Each stone is not a simple rectangle. It is a unique polygon, its faces carved with subtle concave and convex surfaces that create a stable, interlocking puzzle. This is not just about fitting stones together. It is about distributing immense weight and resisting seismic forces for millennia. Now picture the scale. How do you transport a single block of stone weighing 1,000 tons? A mass equal to 2 fully loaded jumbo jets across miles of rugged terrain. How do you then lift it and place it with such care that it kisses its neighbor without a gap? The sheer logistics are staggering, suggesting a depth of knowledge in engineering, physics, and material science that we are only beginning to appreciate. This level of craftsmanship is not an isolated wonder. It is a ghost, a signature of a lost technology that appears on different continents, calling us to question what we think we know about the ancient world. From the high Andes, this enigma of stone echoes across the entire world. If you were to trace a line connecting the greatest stone marvels on a map, it would circle the globe. The massive heads of Easter Island stare from their remote Pacific home. The colossal foundation stones of Baalbek in Lebanon rest with impossible weight. In Egypt, deep within the Serapeum of Saqqara, lie granite boxes weighing over 100 tons each. Their surfaces are so smooth, their corners so perfectly sharp, that many observers say they resemble the work of a massive, precise machine rather than the hand of a stone worker with a hammer and chisel. Across the world in Japan, the Ishi no Hoden stone rises from a pond, its face polished to a reflective sheen that mirrors the water around it, a feat of finishing that seems to belong to a different age entirely. How can this be? How can cultures separated by vast oceans and by thousands of years produce stonework that shares the same signature of perfection? The polygonal walls of Cusco in Peru, where stones lock together in a dizzying jigsaw puzzle, find a strange cousin in the massive trilithons of Stonehenge in England, where giant stones were shaped and joined with a focus on stability and precision. Researchers like Graham Hancock have pointed to these overwhelming similarities as a possible clue. He suggests these achievements might not be isolated miracles of individual cultures, but fragments of a much older, shared inheritance. The idea is that a common thread of knowledge, or perhaps even a lost global civilization, left its blueprint behind, a blueprint that different cultures rediscovered and applied in their own unique ways. The evidence is not just in the grand scale, but in the minute details, the universal preference for certain rock types like granite and basalt, materials known for their incredible hardness. The recurring use of polygonal shapes that interlock, a design that naturally resists earthquakes, the pursuit of that seamless joint, that impossible fit, which appears to be a shared global standard. This points to something far deeper than coincidence. It suggests these ancient builders were not just artists or laborers. They were master engineers who understood the very soul of the stone, possessing a unified science that we are still trying to decipher. So what kind of tools could possibly leave such a mark on the world? What forgotten methods could slice through granite as if it were soft clay? Granite is one of the hardest stones on Earth. To shape it with the precision we see in ancient monuments would require tools of immense strength and durability, yet the official record is curiously silent. We are told that copper chisels and stone hammers were the pinnacle of ancient technology, but step into a modern stonemason's workshop and try that for yourself. Master stonemason Roger Hopkins attempted to use these proposed ancient tools on hard stone, and the results were telling. The soft copper chisels blunted almost instantly, making fine, precise work impossible. They could perhaps rough out a shape, but they could never achieve the glass-smooth surfaces and the mathematically perfect angles found at places like the Serapeum of Saqqara. Even with today's diamond-tipped saws and grinders, replicating the finish on those 100-ton granite boxes is a tremendous challenge. This creates a fascinating conundrum. If the tools we credit to the ancients are demonstrably insufficient, what were they really using? The evidence is not in a lost toolbox but in the stones themselves. Look closely at the tool marks left behind. On certain Egyptian artifacts like unfinished obelisks, we see clear evidence of drilling. The holes drilled into granite show a consistent, deep spiral groove, a signature that suggests a drill bit that was not just handheld, but was powered, spinning with immense force and speed. The rate of penetration implied by these grooves is so advanced that it points to the use of a rotary tool, something we would not expect to see for thousands of years. This has led researchers to explore other, more exotic possibilities. Could sound have been a tool? The concept of using specific sonic vibrations to soften or manipulate stone appears in various legends. While it may sound like science fiction, the idea is that a precise resonant frequency could potentially make crystalline structures in rock more malleable, allowing for easier shaping. Another compelling theory involves the use of advanced, lost abrasives. Perhaps the ancient craftsmen possessed a formula for a paste or slurry, a substance far more effective than sand, that when applied with a simple sawing motion, could slice through granite with astonishing ease. Microscopic analysis of some cut surfaces does reveal the use of an abrasive material, but the efficiency and scale of the work suggest it was something extraordinary. The puzzle of the missing tools forces us to ask a profound question. What if the ancients had access to a form of technology we have simply failed to recognize, a method of working stone that was so effective its very principles are now forgotten? To understand the scale of this loss, we must visit the places where this knowledge was applied in its most spectacular form. The scattered stones of Puma Punku do not look like ruins. They look like the components of a vast, disassembled machine, flung across the Bolivian highlands by some forgotten cataclysm. Here, the mystery of lost technology sharpens to a razor's edge. The most iconic pieces are the H-shaped blocks, each one a masterpiece of geometric perfection. They are not just similar, they are identical, featuring the same precise notches, the same exact grooves, cut into one of the hardest stones on the continent, andesite. To work andesite, which is harder than steel, with this level of repeatable accuracy, suggests a concept that feels utterly anachronistic: prefabrication. It is as if these stones were not individually carved by hand, but produced in a series from a single, perfect template. Anthropologist Arthur Posnansky, who dedicated much of his life to studying this site, noted that the entire complex was laid out with sophisticated astronomical alignments, integrating complex engineering with a deep understanding of the cosmos. But the construction itself defies logic. How were these blocks made? The surfaces are flawlessly smooth, meeting at perfect 90-degree angles that would challenge a modern mason even with powered tools. Drill holes perfectly cylindrical pierce the stone, implying the use of tubular drills that could somehow bite into this incredibly resistant material. Then there is the famous keystone, a block of such intricate complexity it seems to defy its own solidity. It is crisscrossed with shallow, perfectly cut channels, so precise and regular that many researchers believe they were designed to hold metal clamps, perhaps to join these massive components together without mortar. This level of modular design, where every piece is made to fit a grand, preordained plan, is the kind of thinking we associate with modern assembly lines, not with an ancient culture that, as far as we know, did not even use the wheel. The puzzle of Puma Punku forces a profound question. Could a society achieve this without the machinery we assume is necessary? Or does this site stand as silent, stubborn evidence for a different kind of knowledge entirely? A science of stone that allowed its practitioners to shape the earth itself with an ease we can scarcely comprehend. This idea of a forgotten science leads us to another global hotspot, where the stones are not just precisely cut, but moved across impossible distances. Deep within the sands of Egypt, the Serapeum of Saqqara presents a different kind of perfection. Descending into its silent, underground tunnels feels like entering a factory for giants. Here, 24 massive boxes are carved from a single piece of solid Aswan granite, a material so hard it quickly destroys modern cutting tools. Each sarcophagus weighs over 100 tons, and their presence in this subterranean complex raises a question that echoes louder than any footstep. What were these impossibly precise containers really for? Engineer Christopher Dunn has studied these boxes extensively, and his conclusions challenge everything we assume about ancient technology. He argues that the symmetry, the surface finish, and the incredible flatness of the stone point to the use of machinery for milling and drilling, tools that should not have existed for thousands of years. Look at the internal corners of these boxes. They are not just square, they are sharper than what many of our own modern saws can produce, forming a perfect, crisp intersection that seems to defy the granular nature of stone. The lids are a marvel in themselves. They were cut from the same block of granite as the boxes they seal, and they fit with such flawless precision that they are virtually airtight and watertight. The flatness of these surfaces has been measured to within 1/10,000th of an inch, a level of accuracy that rivals the standards we use today for optical lenses and laser components. This is not merely skilled craftsmanship, it is a demonstration of high-precision engineering. While these boxes were later used for the ceremonial practices surrounding the Apis bulls, their original purpose remains shrouded in mystery. The sheer effort required to achieve this kind of finish on granite suggests a function far beyond a simple resting place. Why would a culture invest such an unimaginable amount of labor and sophisticated knowledge to create a container that needed to be sealed with near-perfect precision? Were they trying to preserve something or to contain something that demanded this level of exactitude? The granite boxes of the Serapeum stand as a silent testament to a science we can measure with our finest instruments but cannot explain with our conventional history. They force us to wonder if the true purpose of these places was not just to honor the past, but to preserve a knowledge so advanced it appears to us as magic. High in the Andes, the walls of Sacsayhuaman and Ollantaytambo are a living lesson in ancient engineering. Here, stones weighing hundreds of tons are fitted together in a colossal, three-dimensional jigsaw puzzle, a structure that has withstood powerful earthquakes for centuries. The secret lies in the polygonal masonry. Each block is a unique shape with multiple interlocking angles and faces. This is not a simple wall, it is a flexible, breathing structure. When the ground shakes, the stones shift and settle, distributing the immense forces evenly before locking back into place. The joints are so tight that after hundreds of years they remain seamless. One of the most baffling aspects for archaeologists is the near-total absence of tool marks on the finished stones. There is no evidence of the pounding and chipping we would expect from stone hammers. This has led to a fascinating question: how was this achieved without leaving a trace? Some researchers point to indigenous oral traditions that speak of a knowledge now lost, of a special plant extract that could be applied to the surface of the rock, temporarily making it soft and malleable like clay. While this may sound like a legend, it offers a potential explanation for how these intricate shapes could be worked with such precision. The mystery only deepens when we consider the journey these stones took. At Ollantaytambo, the massive red granite monoliths were quarried from a mountainside several miles away, across the roaring Urubamba River and up a steep valley. How were these immense blocks, some weighing well over 100 tons, transported and then lifted into position high on a terraced hillside? The conventional explanation of ropes, logs, and earthen ramps feels insufficient for the sheer scale and precision of the task. The logistical coordination required is staggering, suggesting a profound understanding of physics and organization that challenges our perception of what was possible. These sites force us to look beyond simple tools and consider the possibility of a different kind of knowledge, one that understood the very nature of stone and how to command it. Legends speak of a time when stone could be softened like clay. Across the Andes, the story of the god Viracocha is told, a being who carried a plant with the power to dissolve rock, allowing massive stones to be shaped and set with ease. This is not an isolated tale. Similar accounts from other ancient cultures describe methods for making hard stone malleable. Could these stories be a cultural memory of a real, lost technology, a way to temporarily defeat the hardness of granite and andesite? This is the core of the controversial soft stone theory. It proposes that ancient builders might have used a chemical or thermal process to alter the very structure of the stone, working it in a plastic state before it hardened again into its final, impossibly precise form. Researcher Joseph Davidovitz has championed one version of this idea with his geopolymer theory. He suggests that some ancient stonework, particularly in Egypt, was not quarried and carved but cast. According to this view, builders could have crushed natural stone, mixed it with a special alkaline binder to create a kind of synthetic rock slurry, and then poured it into molds like modern concrete. This would elegantly explain the lack of tool marks and the perfect, seamless fits between blocks. Yet, for all its appeal, the geopolymer theory faces significant hurdles. It struggles to account for the massive, single crystal granite blocks found at sites like the Serapeum, where the stone's internal crystalline structure is continuous, proving it was carved from a solid piece, not cast. So if it was not a casting process, what could cause solid rock to behave as if it were soft? Look closely at the foundations of the Coricancha temple in Cusco. Here, some of the andesite stones have a peculiar, almost glazed appearance, as if their surface was once in a semi-liquid state and has now vitrified, turning into a glass-like layer. This vitrification is a telltale sign of exposure to extreme, concentrated heat far beyond what a simple campfire could produce. What natural process or what forgotten alchemy could generate temperatures high enough to melt the very surface of the stone, allowing artisans to mold and fuse it? Some experiments have shown that certain plant acids can chemically weaken the bonds in silicate rocks, making them easier to abrade. Perhaps the legendary plant of Viracocha was not a magic substance, but a potent chemical agent derived from nature. Another possibility involves focusing sunlight with massive lenses or mirrors, creating a heat source so intense it could vitrify stone. While these ideas push the boundaries of conventional archaeology, they force a necessary question. If our current explanations for how these stones were worked are insufficient, then we must be open to investigating all possibilities, no matter how extraordinary they seem. The evidence carved into the stone itself points toward a method that treated rock not as an unyielding solid to be conquered by force, but as a material that could be persuaded, softened, and commanded. This line of thinking inevitably leads us to an even more profound mystery, one that lies not in the chemistry of the stone, but in the sheer physics of moving it. The legends speak of stones that floated on the rhythm of song. Inca oral histories tell of priests who used specific chants, their voices resonating with a power that lightened massive blocks, guiding them effortlessly into place. This same idea appears halfway across the world, in ancient Tibetan texts that describe monks using massive trumpets and drums to generate a collective sound so potent it could lift stones up a mountainside. For centuries, these stories were dismissed as pure myth, but modern physics is beginning to reveal a startling truth that sound can indeed move matter. In laboratories today, scientists use ultrasonic speakers to create standing waves, pockets of intense acoustic pressure that can suspend tiny droplets of water or small pieces of solid material in mid-air. The principle is based on resonance, finding the exact vibrational frequency of an object. When that frequency is matched and amplified, it can create forces that oppose gravity itself. So could this principle be scaled up? Could a culture have discovered a way to use resonant sound to negate the immense weight of a 100-ton block of granite? The logistical challenge of building the Great Pyramid, where millions of blocks were placed with pinpoint accuracy, becomes less impossible if the stones were not dragged but guided. If the weight of a block could be significantly reduced through acoustic means, a small team of workers could maneuver it with a fraction of the effort. The evidence is not in a recovered machine, but in the peculiar acoustics of some ancient sites themselves. Certain chambers and passageways within pyramids and temples are known to produce strange sonic effects, amplifying specific frequencies and creating a palpable vibration in the air. Were these spaces designed not just for ceremony, but as resonant chambers for a forgotten technology? This forces a profound question. What if the ancients understood a fundamental relationship between vibration and matter that we are only now rediscovering? What if their greatest tools were not made of copper or iron, but were invisible waves of sound harnessed to shape the world? This concept of a hidden force in nature leads us to another compelling piece of the puzzle, one written not in legend, but in the very rock beneath our feet. The stone itself was a willing partner in this ancient collaboration. Across the globe, builders did not simply fight against rock. They worked with its very nature, selecting specific types for their unique properties. At Puma Punku, the choice of andesite was no accident. This fine-grained volcanic stone is incredibly hard and dense, allowing artisans to carve the sharp, intricate edges of its famous H-blocks without the material crumbling. Similarly, the towering pillars of Göbekli Tepe, among the world's oldest known megalithic structures, are crafted from a particularly resilient form of limestone and basalt, materials chosen to withstand millennia of exposure. Petrologists, scientists who study rock, note that the size of a stone's crystals, its grain, is critical. A fine-grained stone, like the andesite of the Andes or the black basalt of Baalbek, acts like a superfine sandpaper, permitting the creation of near-perfect flat surfaces and razor-sharp corners that would be impossible in a coarse, pebbly granite. This was a deep understanding of material science. The ancient masons were not just artists, they were master geologists who could read a stone's potential from the quarry face. Their first step was often to exploit the stone's own weaknesses. They would meticulously search for natural fracture lines and planes of weakness within the bedrock. At the unfinished obelisk in Aswan, Egypt, we see this principle frozen in time. This colossal monument, which would have been the largest ever attempted, was being carved directly from the living granite. The workers carved a channel around its perimeter, and then, rather than trying to cut it free, they drove wooden wedges into this channel. They then soaked these wedges with water. As the wood expanded with tremendous, inexorable force, it pressured the granite along its natural crystalline grain, cleanly separating the obelisk from the bedrock below. This method of thermal or hydraulic splitting was a brilliant application of physics, using controlled stress to do the work of 1,000 hammers. The selection of a quarry was therefore a decision of supreme importance. Why travel miles for a specific type of stone? The answer lies in consistency and quality. A superior quarry offered bedrock with minimal internal flaws, consistent grain, and the right hardness for both transport and final carving. Before committing to a massive project, builders would test the stone, perhaps by carving a small section to see how it responded to their tools, ensuring it would not fracture unpredictably. This intimate knowledge of geology, this ability to listen to what the stone itself was saying, formed the essential foundation for everything that followed. It was the first step in a process that would soon demand a language far more complex than simple quarrying, a language written in the universal constants of mathematics and celestial alignment. The stones themselves are a library of forgotten mathematics. Carved into these silent, enduring forms is a language of geometry so precise it seems to speak directly to the cosmos. This is not the crude geometry of simple shapes, but a sophisticated application of sacred ratios and universal constants. At the Giza Plateau, the dimensions of the Great Pyramid encode the mathematical value of pi, the ratio of a circle's circumference to its diameter, with an accuracy that stuns modern observers. The perimeter of its base, divided by twice its height, yields a figure astonishingly close to pi. How could a culture without advanced calculus incorporate such a fundamental constant into their architecture on such a colossal scale? Mathematician John Michell spent his life studying this phenomenon, noting that the layout of sacred sites often reflects what he called canonical design, a system of proportions based on the golden ratio known as phi. This ratio, approximately 1.618 to 1, appears repeatedly in nature, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. Its presence in ancient monuments suggests the builders saw their work as a mirror of the natural world, a physical echo of a divine order. This mathematical mind is also visible in the very way the stones fit together. The polygonal walls of Cusco are a masterclass in applied geometry. Every block is a unique polygon, yet they all fit together in a seamless, gap-free mosaic. This required an intuitive grasp of how complex shapes could interlock in 2 and 3 dimensions, a puzzle solved without the aid of paper or computers, conceived and executed directly in stone. The same genius for form appears in the mysterious stone spheres of Costa Rica. These nearly perfect orbs, some weighing over 15 tons, were carved from hard volcanic rock with such skill that their diameters vary by less than a centimeter. Creating a true sphere by hand is a task of almost unimaginable difficulty. It demands a constant, unwavering understanding of curvature and radius from every single angle. What tools could possibly allow an artisan to maintain that perfect symmetry, to feel the geometry in their hands as they worked? The presence of these spheres, along with the encoded pi and phi in the pyramids, points to a shared, profound knowledge. It was a knowledge that saw mathematics not as an abstract exercise, but as the living framework of reality itself. They were not just building structures, they were weaving the very constants of the universe into their work. This deep connection between earth and sky inevitably leads our gaze upward to the stars that guided their hands. The stars were their blueprints, Long before the invention of the telescope, ancient engineers across the world looked to the heavens, using the predictable motions of the sun, moon, and stars to anchor their colossal stone creations to the cosmos. At Stonehenge, the summer solstice sunrise breaks directly over the heel stone, casting a beam of light that travels the length of the monument's central axis. This was not a chance alignment. It was a carefully engineered event, a calendar in stone that marked the turning of the seasons with unerring accuracy. In the deserts of Peru, the vast geoglyphs known as the Nazca lines may seem like random patterns from the ground, but from above, some researchers suggest their sprawling forms mirror constellations in the night sky, turning the entire plateau into a celestial map. According to insights from archaeoastronomer Giulio Magli, these structures often functioned as both observatories and calendars, their alignments encoding a deep understanding of cyclical time. But how did they achieve such pinpoint precision without any optical instruments? Their methods were deceptively simple yet brilliant. They used the land itself as their guide. By placing horizon markers on distant hills, they could track the rising and setting points of celestial bodies as they shifted throughout the year. They measured the subtle changes in shadow lengths cast by a central gnomon, a simple upright stone. A longer shadow meant the sun was lower in the sky, marking the winter solstice, while a short, sharp shadow signaled the height of summer. At Machu Picchu, the Intihuatana stone, often called the hitching post of the sun, stands as a perfect example of this genius. Its carved angles and pillars are positioned to capture the sun's rays at the equinoxes and solstices, creating specific shadow effects that would have been vital for timing planting and harvest seasons. So why was this cosmic connection so vital? For these cultures, the universe was a single, interconnected whole. Aligning their most enduring structures with the heavens was a way to bring cosmic order down to earth, to harmonize human life with the divine rhythm of creation. Their monuments were not just buildings, they were statements of belonging in a vast, intelligent universe. This profound spiritual motivation raises the ultimate question: what were they trying to communicate, not just to the stars, but across the expanse of time itself? These monuments of impossible precision were far more than engineering exercises. They were profound expressions of belief, where every seamless joint and perfect angle was an act of reverence. Stand in the great temple of Angkor Wat at dawn, and you feel it, a silent resonance emanating from the stone itself. Every surface, every corridor is a canvas for divine stories, a physical prayer carved into the world. Anthropologist Mircea Eliade described such places as axis mundi, the sacred centers of the world, pillars that connected the earthly realm directly to the heavens. The perfect stonework was not just for show, it was a deliberate act to create a stable, eternal point of contact with the divine, a place of order in a chaotic world. This drive for perfection was a spiritual imperative. In the marble temples of India, built by the Jain community, the flawless, mirror-smooth carving of every statue and pillar is not merely an aesthetic achievement. It is a direct reflection of a core spiritual principle, the pursuit of inner purity and the shedding of all karmic baggage. The perfection of the stone was meant to mirror the perfection of the soul. So what drove entire cultures to pour generations of labor into these projects, to move mountains of stone with such devotion? The answer lies in a fundamental human need, the desire to create something that would outlast the fleeting span of a single life, to weave their understanding of the cosmos into the very fabric of the earth. This was a collaboration with eternity. The precision ensured the structure would stand for ages, a permanent home for the gods and a testament to a people's place in the universe. It was a way to achieve harmony with the natural forces they revered, building in alignment with the stars and the earth to create a true sanctuary. This monumental ambition, however, demanded more than faith alone. It required the mobilization of entire societies, raising the inevitable question of how such immense projects were organized and who performed this back-breaking work. Moving an 800-ton block of stone is like trying to transport a small building across a rugged landscape. The trilithon stones at Baalbek in Lebanon, each one a colossus weighing nearly 1,000 tons, were somehow dragged from a quarry over a mile away. On Easter Island, the massive Moai statues, some weighing over 80 tons, were transported miles from the quarry to their final coastal platforms. How do you even begin to orchestrate such a feat? The primary challenge is friction. The sheer weight of these stones creates an immense resistance with the ground, a force that would seem to make movement impossible. Modern experiments led by archaeologists like Mark Lehner have demonstrated one potential solution. Using a sledge on a prepared track, a large team of people can pull a heavy load, but the friction is still immense. The breakthrough comes with lubrication. By wetting the path in front of the sledge with water, the friction is drastically reduced, turning a near-impossible drag into a slow, steady pull. This simple yet brilliant application of physics could explain how the stones of Baalbek inched their way to their destination. Yet, the terrain itself presents another layer of complexity. The journey for the Incas at Ollantaytambo was not across flat ground, but up the steep side of a mountain valley. Here, the evidence suggests they constructed massive earthen ramps, a temporary landscape of earth and stone that allowed workers to haul 100-ton blocks to breathtaking heights. They also used a system of levers and ropes, a careful, incremental process of lifting and pivoting to navigate cliffs and impossibly narrow passages. This was not brute force, but a masterful application of mechanical advantage. The coordination required for these operations is almost beyond comprehension. How do you direct thousands of workers to pull in perfect unison on a rope without a written plan or a modern communication system? The answer likely lies in rhythm and sound, perhaps a unified chant or the beat of a drum that synchronized every heave and every step. This transforms the effort from a chaotic struggle into a coordinated, rhythmic dance, a shared human engine capable of moving mountains. These logistical marvels reveal an ancient engineering knowledge that was deeply practical, born from a profound understanding of simple machines, material behavior, and human organization. They saw a problem of immense physical scale and solved it not with magic but with a brilliant collective intelligence. The ancient engineer did not have a textbook, yet they understood the physics of stability on an intuitive level. Their secret was a profound mastery of stress vectors, the invisible lines of force that pass through a structure. Every stone was shaped to redirect these forces, channeling immense weight away from weak points and distributing it safely into the ground. Look at the foundation stones of some Inca walls, their bases carved with a subtle concave curve. This was not an aesthetic choice. It created a stable, rocking base that allowed the entire wall to sway as a single, flexible unit during an earthquake, settling back into perfect alignment once the shaking stopped. Modern civil engineers who study these walls express a deep admiration for their seismic resilience, a quality many of our own rigid structures struggle to achieve. These builders grasped the principle of the center of gravity with the skill of a modern physicist. Consider the raising of an Egyptian obelisk, a needle of stone weighing hundreds of tons. This was a breathtakingly delicate operation, a slow, precise pivot that relied entirely on a counterweight system. As the base was lifted incrementally, the mass of the stone itself, combined with carefully placed sandbags or earth ramps, acted as a counterbalance, preventing a catastrophic tumble and guiding the monolith gracefully into its vertical position. The Romans later perfected the use of massive treadwheel cranes and complex pulley systems, human-powered machines that could lift staggering weights. But one wonders if even earlier cultures possessed methods that were somehow more efficient, now lost to time. They manipulated mass and leverage not with complex formulas, but with a hands-on wisdom born from generations of observation. They knew that to move a heavy object, you do not fight its weight, you use it to your advantage. This ancient empirical science of stability and motion rivals our own in its elegant simplicity. It forces us to ask if our modern approach, with its reliance on steel reinforcement and power tools, has perhaps forgotten some of the quieter, more profound secrets of working in harmony with the natural forces of the earth. A team of modern engineers stands before a block of andesite, armed with computer-guided lasers and diamond-tipped saws. Their goal is to recreate one of the iconic H-blocks from Puma Punku, to match its perfect 90-degree angles and seamless surfaces. The machinery hums, the lasers trace their paths, and after days of meticulous work, they produce a block that is incredibly precise by our standards. Yet when placed next to the ancient original, subtle differences emerge. The modern copy, for all its technological might, cannot quite capture the flawless, almost liquid smoothness of the surface. It cannot replicate the mysterious, uniform consistency of the stone itself. The project takes weeks, a fraction of which the ancients would have had for an entire complex. This is the humbling reality of modern replication. We can achieve similar forms, but we do so through brute force technology, consuming immense time and energy, while the ancients seem to have achieved their results with an elegant efficiency we cannot yet grasp. This gap becomes even more personal at a place like the Coral Castle in Florida. Here, one man, Edward Leedskalnin, single-handedly quarried, carved, and positioned over 1,000 tons of coral rock. He claimed to understand the secrets of the pyramids, the secrets of weight and leverage. He worked mostly at night, shrouding his methods in mystery, and when asked how he moved the massive blocks, he would only say he understood the laws of weight and leverage. Modern engineers have tried to replicate his feats using the simple tools he was known to have, like chain hoists and tripods, and they consistently fall short. They can move the weight, but not with the speed and grace that one man working alone seemed to possess. The difference is stark when you compare the results of experimental archaeology. When skilled stonemasons use only copper chisels and stone hammers on a block of Aswan granite, the result is a rough, pitted surface covered in the scars of countless impacts. It is a testament to immense human effort, but it looks nothing like the mirror finish on the boxes in the Serapeum. At the very quarry that supplied the ancients, the unfinished obelisk, modern attempts to split granite using the same proposed ancient methods of fire and water or wooden wedges have ended in failure, resulting in fractured, unusable stone rather than a clean separation. So why does our advanced technology struggle to match their quiet mastery? Is it simply that we have lost the patience, the generations of handed-down tactile knowledge that allowed an artisan to feel the stone and understand its soul? Or is the gap in our understanding even more fundamental, a missing piece of physics or material science that they possessed and we have yet to rediscover? This question lingers in the quiet spaces between the stones, and it draws us toward the oldest libraries of all, the stories passed down by voice through countless generations. The stories of the elders carry a different kind of evidence, one that lives in the breath and memory of a people. In the high Andes, whispers persist of a time when the great stones of Sacsayhuaman were not dragged, but guided by the rhythm of sacred chants, their immense weight seemingly lifted by the power of sound alone. These are not mere fantasies, but specific oral histories passed down through countless generations, and they find a startling echo halfway across the world. In the ancient Mesopotamian epic of Gilgamesh, there are references to tools that could cut through the hardest rock as if it were soft fruit. The Popol Vuh, the sacred text of the K adjective ICHE adjective Maya, speaks of the first creators who had the ability to see straight through stone, to understand its hidden nature and command it. For a long time, these accounts were dismissed by mainstream scholarship as pure mythology, the symbolic language of a pre-scientific world. But what if we have been misreading them? What if these stories are the cultural containers for a lost science, a way of preserving technical knowledge that was too valuable to be forgotten, even when the methods themselves were lost? Consider the Maori legends of New Zealand, which tell of the Patupea, a mysterious, pale-skinned people who possessed supernatural building skills and could move great stones with ease. These narratives often describe the use of specific plants or herbs that, when applied to the surface of a rock, would make it temporarily soft and pliable like clay. This directly parallels the Andean stories of the god Viracocha carrying a plant that could melt stone. A kernel of practical truth may lie within this legend. Modern experiments have shown that certain organic acids found in plants can indeed chemically weaken the silicate bonds in some types of stone, making them significantly easier to carve or abrade. It is not magic, but a forgotten application of natural chemistry. Other traditions speak of levitation devices, of mirrors that gathered sunlight with such intensity they could slice through granite, or of strange, resonant instruments that altered the weight of objects. While we cannot take these descriptions literally, they could be metaphorical attempts to describe technologies that were so advanced they appeared as supernatural forces to later generations. They point toward principles of acoustics, optics, and energy manipulation that we are only now beginning to formally understand with our own physics. The central lesson from these oral traditions is not that ancient people had magic wands, but that they possessed a profound empirical understanding of their environment. They knew which plants produced potent chemical reactions. They understood how sound waves could interact with matter. They observed natural phenomena and learned to harness them in ways we are still struggling to comprehend. These stories are a bridge connecting the tangible evidence in the stone to the intangible wisdom of the human spirit. This deep connection to the natural world extended beyond the earth itself, reaching for the stars, and it is in the silent language of celestial alignment that we may find the next piece of this ancient puzzle. Rain falls for 1,000 years, and even the hardest stone begins to tell a new story. The surfaces of ancient monoliths have been slowly reshaped by wind and water, their original sharpness softened by the relentless patience of nature. At the breathtaking city of Petra, carved directly into rose-red cliffs, the wind has scoured intricate facades, blurring details that were once crisp and clear. Off the coast of Japan, the submerged terraces of the Yonaguni Monument are worn smooth by ocean currents, their edges rounded and their surfaces covered in marine life, leaving archaeologists to debate whether they are a natural formation or a structure altered by time. This natural erosion presents a unique challenge, as the patterns left by millennia of weather can sometimes perfectly mimic the marks of ancient tools, complicating our attempts to understand the builder's original methods. Geologists studying these sites must learn to read the stone like a historical document, distinguishing between the story written by human hands and the one written by the elements. This raises a pivotal question: how much of the perfection we seek has simply been worn away? The Great Sphinx of Giza stands as the most famous example of this mystery. The deep, vertical fissures covering its limestone body are consistent with erosion caused by extensive rainfall, not wind and sand. This type of water erosion suggests the Sphinx could be vastly older than the commonly accepted timeline, potentially dating back to a period when the climate in Egypt was significantly wetter. If true, this would mean the monument has been silently watching over the plateau for many thousands of years longer than we thought. Its original form perhaps far more refined than the weathered figure we see today. It appears the ancient builders were not ignorant of this slow, inevitable transformation. In many places, they designed their structures to withstand it. Look at the massive stone heads on Easter Island, the Moai. Their creators positioned them with great care, often incorporating subtle overhangs into the design that helped channel rainwater away from the most detailed carvings on their backs. There is also evidence that some cultures used protective coatings, mixtures of plant resins or mineral paints, to seal the stone surface and shield it from the elements. This reveals a forward-thinking mentality, an intention for their work to endure not just for generations but for epochs. So when we look at a weathered monolith and see only a rough, ancient rock, we must ask ourselves, are we seeing the limits of ancient ability, or are we seeing the effects of an unimaginable span of time? The perfection we so admire may have been even more astonishing on the day it was new, a thought that deepens the mystery and pulls us further into the debate over the true age and purpose of these silent, enduring sentinels. The true age of these monuments is a battlefield of science, fought not with shovels but with isotopes and atomic clocks. Deep inside a modern laboratory, a quiet revolution is challenging the very timeline of human history. The primary tool for dating ancient objects has long been radiocarbon dating, a method that measures the decay of carbon-14 in organic material. But here lies the fundamental problem. Many of the world's most precise megalithic sites are built entirely of stone, offering no wood, no bone, and no charcoal for this technique to analyze. The stones themselves are silent, refusing to give up their secrets so easily. This has forced researchers to turn to other, more complex methods, and the results are shattering our conventional timelines. Geologist Robert Schoch became a central figure in this debate through his analysis of the Great Sphinx. He argued that the deep weathering on the Sphinx's body was caused by water, specifically extensive rainfall, which would place its construction in a period when the Egyptian climate was far wetter, potentially as far back as 10,000 years before the Common Era. This geological evidence stands in stark contrast to the traditional archaeological dating, which places the Sphinx at around 4,500 years old. The conflict is clear. Does the stone itself tell a more accurate story than the artifacts found near it? To break this deadlock, scientists employ techniques like thermoluminescence, which can date the last time a crystal in stone or pottery was heated by a fire, or uranium-thorium dating, which measures the decay of uranium into thorium in limestone formations like stalactites that grow over a structure. It was the application of such methods to the site of Göbekli Tepe in Turkey that sent shockwaves through the archaeological community. This complex of carved, T-shaped pillars was dated to around 9,600 years before the Common Era, pushing the dawn of complex stonework thousands of years further back than anyone had believed possible. If such sophisticated engineering existed at the very end of the last ice age, what else might we have gotten wrong? The debate extends to the Great Pyramid, where some researchers point to geological and astronomical alignments that could also suggest a much older origin, perhaps even coinciding with that same distant epoch. What if our entire understanding of civilization's cradle is built upon a timeline that is fundamentally incomplete? These scientific controversies do more than just adjust a calendar. They open the door to alternative historical narratives where the fingerprints of a lost chapter in human ingenuity are etched into stone all across the globe. Plato's story of Atlantis was not just a fable, but a warning of a great civilization swallowed by the sea. This idea of a predecessor culture, a society with advanced knowledge that vanished after a global cataclysm, challenges the very foundation of our history. Authors like Ignatius Donnelly argued in the 19th century that these stories were not myths, but fragmented memories of a real, global society whose achievements were lost in a great reset. The evidence, they suggest, is not in a single city, but in the shared architectural fingerprints found on every continent. How else can we explain the same precise stonework appearing in the Andes, across the Pacific, and in the Mediterranean, unless these cultures were drawing from a common, older source of knowledge? These theorists point to the countless flood myths that appear in nearly every ancient culture, from the Mesopotamian epic of Gilgamesh to the legends of the Maya. These are not seen as mere coincidences, but as a collective human memory of a real, devastating event, perhaps a rapid rise in sea levels at the end of the last ice age that could have erased the coastal centers of an early advanced society. Off the coast of Yonaguni, Japan, massive submerged terraces and what appear to be carved steps lie deep below the waves. Mainstream geologists often attribute these formations to natural erosion, yet the sheer geometry and repetitive right angles compel some researchers to ask if we are looking at the sunken ruins of a forgotten epoch. The mainstream archaeological view remains one of healthy skepticism. They point to a lack of conclusive evidence, such as manufactured tools or evidence of habitation, in a stratum that would support such an ancient timeline for complex civilization. They argue that independent invention and the universal challenges of working stone can explain the similarities without requiring a lost global culture. Yet the question lingers, forcing a profound reflection on the nature of human progress. Is civilization a steady, linear climb, or is it a cycle of rise and collapse where knowledge is won, lost, and then won again over vast spans of time? The psychological impact of these mysteries is deep, touching a chord within us that wonders if we too could forget, if the greatest discoveries of our own age might one day become the indecipherable monoliths of a future era. There is a quiet hum that seems to rise from the stones of Stonehenge at dawn, a vibration felt not in the ears but in the soul. This profound sense of awe is a universal human experience, a pull toward these ancient sites that defies simple explanation. Why do these perfectly carved monoliths hold such power over our imagination? Psychologist Carl Jung might have said it is because they speak to a deep part of our shared consciousness, to archetypes buried within us all. The monolith is a symbol of the eternal, an object that stands unyielding against the relentless flow of time, and we are instinctively drawn to its promise of permanence. It represents a mystery that our modern, data-driven world cannot easily solve, and this challenges our most fundamental assumptions. We are taught that human history is a story of linear progress, a steady climb from primitive tools to sophisticated technology. Yet the evidence carved in stone suggests a startling possibility that ancient cultures may have possessed a kind of knowledge we have not yet rediscovered. This idea resonates because it taps into a deep-seated curiosity about lost worlds and forgotten wisdom. The immense popularity of television shows exploring alternative history is a testament to this yearning. These programs, while speculative, fulfill a profound human need to question the official narrative and to wonder if the past was far more complex than we have been led to believe. Our fascination is not really about finding little green men. It is about the unsettling and thrilling notion that we might have something fundamental to learn from our ancestors. It forces us to confront the fragility of our own civilization and the knowledge we hold so dear. Could our own achievements one day become a similar puzzle for a future society to decode? This captivating dialogue between our past and our present has inevitably spilled over from academic journals and into the very fabric of our modern culture, shaping the stories we tell about ourselves and our place in the universe. This magnetic pull of the ancient world does not end at the edge of an archaeological site. It flows directly into our cinemas and living rooms, transforming these stone enigmas into the bedrock of modern myth. The weathered stones of forgotten cities become the dramatic backdrop for Indiana Jones, where the quest for a lost artifact is a thrilling race against time, weaving archaeological curiosity with high-stakes adventure. Filmmakers like Roland Emmerich have built entire blockbuster narratives around the idea of a global cataclysm that wipes out a sophisticated ancestor culture, their advanced technology buried with them. Emmerich himself has noted the public's deep fascination with apocalyptic themes tied to these lost civilizations, a fascination that speaks to our own collective anxieties about the durability of our modern world. These stories are more than simple entertainment. They are powerful vessels that carry the mystery of the monoliths to a global audience, shaping how millions perceive humanity's distant past. The line between documented fact and cinematic fiction often blurs in this process. A documentary focusing on the geometric perfection of Puma Punku can spark vigorous online debate, with its compelling visuals and speculative theories leaving a more lasting impression on many viewers than a dry academic paper ever could. This cultural footprint extends even to our virtual worlds, where video games construct entire universes around exploring ancient, ruined megastructures built by vanished races, placing the player directly into the role of the intrepid explorer. Why does this cycle of storytelling feel so endlessly compelling? It is because these media creations tap into the same profound sense of wonder that the original stones evoke. They keep the questions alive and relevant for each new generation, ensuring that the mystery of how these structures were built continues to captivate the public mind long after the credits roll. This widespread cultural engagement, however, brings with it a significant responsibility, raising urgent questions about how we interact with these fragile, irreplaceable sites themselves. A conservator's careful hands gently brush away invasive moss from a 500-year-old wall at Machu Picchu, each movement a delicate negotiation with time itself. These global treasures, having withstood earthquakes and centuries, now face a new and relentless challenge: the sheer volume of human admiration. The soft souls of millions of visitors, while filled with good intention, gradually wear down ancient staircases and polished surfaces. To combat this, preservation teams employ a powerful but invisible tool: three-dimensional laser scanning. These scanners create a perfect digital twin of the entire site, a record so precise it can measure the slow, subtle shift of a single stone over a single season, allowing conservators to intervene with pinpoint accuracy before a minor issue becomes a catastrophic collapse. This is the new frontier of conservation, a global effort led by organizations like UNESCO, but often powered by the deep, personal commitment of local communities who see these monuments as sacred ancestors. The challenges are as varied as the sites themselves. On Easter Island, changing weather patterns and rising sea levels now threaten the coastal platforms of the iconic moai, their stoic faces facing erosion from storms of increasing intensity. Elsewhere, the timeless struggle against thoughtless vandalism, from carved graffiti to unauthorized climbing, inflicts scars that even the most advanced technology cannot always fully erase. Why does this meticulous work matter so profoundly? These stones are not inert rock. They are the primary sources of our shared human story. If they are lost, a unique chapter in the encyclopedia of human ingenuity vanishes with them, a connection to our collective past severed forever. The very same scanners used for preservation are now unlocking new ways to read these ancient stones, revealing secrets invisible to the naked eye and offering a glimpse into the minds of the master builders themselves. A digital ghost of a stone wall now floats in a laboratory computer, its surface mapped with a precision beyond the reach of human touch. This is the new frontier of archaeology, where laser scanners and high-resolution cameras are uncovering secrets locked in stone for millennia. Tools like LiDAR fire millions of laser pulses at a structure, measuring the time it takes for each beam to return, building a point cloud of data that becomes a perfect three-dimensional replica. Through photogrammetry, thousands of overlapping photographs are stitched together by software, creating a model where you can zoom in to see the subtlest scratch or the most gradual curve. This allows researchers to study a site without ever setting foot on it, preserving fragile surfaces from the wear and tear of human contact. One archaeologist working with these models noted that they are not just copies, they are new kinds of historical documents, allowing us to ask questions we never thought to ask before. The true power of this technology lies in its analytical software. It can run algorithms across the digital surface to detect patterns invisible to the naked eye. The software can create a false color map, where shades of blue might represent areas of the stone that are microns lower than areas shaded in red. This reveals the incredible flatness of a sarcophagus lid in the Serapeum, showing a surface so uniform it appears as a single, unbroken color. It can analyze the tightness of a joint between blocks at Saqqara, proving that the fit is not just perfect at the front, but remains seamless deep within the wall. Perhaps the most famous application of this technology was the Scan Pyramids project. By using muon tomography, a technique that senses dense cosmic particles passing through the pyramid, researchers identified large, unexpected voids deep within the Great Pyramid, spaces that could be hidden chambers never documented in any ancient text. What other secrets might these digital eyes reveal? As we build these perfect libraries of stone, we are granted a new vision, one that sees not just the grand shape of a monument, but the faintest whisper of the tool that shaped it. This microscopic evidence is now pointing toward a method so simple, yet so effective, it has been hiding in plain sight all along. The environment was not an obstacle to these master builders, it was their co-architect. In the thin air of the Andes or the relentless desert sun, they did not fight their surroundings, they listened to them, turning environmental challenges into structural advantages. At the high-altitude city of Tiwanaku in Bolivia, builders faced a cycle of freezing nights and thawing days, a process that can shatter ordinary stone over time. Their solution was a stroke of geological genius. They chose andesite, a dense, fine-grained volcanic rock highly resistant to frost. The very material of their monoliths was selected not just for its workability, but for its ability to endure the specific climate it would call home. Environmental archaeologists studying the site have found evidence that the entire complex was engineered with a deep understanding of the El Niño Southern Oscillation. The complex system of canals and drains found there was not merely for show, it was a carefully calculated response to centuries of observation, designed to manage both prolonged droughts and the sudden, devastating floods that characterize this climatic phenomenon. The builders were not just constructing a city, they were building a resilient partner to the very forces of nature. This intimate knowledge of local resources dictated material choices across the globe. Along the Yucatan coast, the Maya faced a scarcity of traditional building stone. Their ingenious answer lay in the sea. They harvested massive blocks of coral, a material that, while softer than granite, was abundant and could be worked with stone tools. They understood its properties, using it to create the foundations of coastal cities that have withstood the humid, salt-rich air for over 1,000 years. This leads to a compelling question. Why would a culture choose the incredible hardship of a mountain peak or a remote island for their most important structures? The answer may lie beyond mere practicality. Building in these challenging, often sacred locations was a declaration of harmony. It was a way to physically anchor their society to the powerful forces of the earth and sky, a testament to a belief system deeply intertwined with the natural world. This shared pattern of environmental adaptation, appearing on different continents, suggests a universal language of practical wisdom, a global conversation between humanity and the elements that may have been one of our most profound and interconnected forms of knowledge. Ancient sea lanes and overland caravan routes formed a vast, invisible web connecting distant cultures long before the age of steam or steel. Could these pathways have carried more than just spices and silks? Could they have transmitted the very blueprint for building in stone? This is the heart of a great debate that divides historians, one that questions whether the global signature of perfect monoliths is evidence of a shared heritage or a stunning example of parallel invention. On one side of this divide sits the theory of cultural diffusion. the idea that knowledge and techniques were passed from one civilization to another through trade, migration, or conquest. Look at the map of the ancient world. The Minoans of Crete were master seafarers, their trade networks stretching across the Mediterranean. From the megalithic temples of Malta, some of the oldest freestanding structures on Earth, these ideas of working massive stone could have traveled north, eventually influencing the great stone circles of Britain. The evidence seems to whisper of contact. Consider the curious case of metal clamps. In ancient Greece, builders used double T-shaped metal clamps to join massive marble blocks, pouring molten lead into the recesses to lock them in place. Thousands of miles away in Peru, at sites like Ollantaytambo, we find the same concept, the same eye-shaped channels cut into andesite blocks, clearly designed to hold metal clamps. Is this a coincidence or the footprint of a shared engineering principle that traversed oceans? Historians like Jared Diamond offer a compelling counterpoint, an idea known as environmental determinism. He suggests that similar environmental challenges in different parts of the world can produce strikingly similar cultural solutions, entirely independent of one another. If you are a culture living in a seismically active region, you will eventually discover that polygonal, interlocking masonry is the most stable way to build a wall that can survive an earthquake. The need to move a 100-ton stone will, through trial and error, lead any society to discover the principles of levers, ramps, and lubrication. In this view, human ingenuity is not a single flame passed from one torch to another, but a series of sparks igniting independently wherever the conditions are right. This debate forces us to look at the evidence with fresh eyes. The pyramids of Egypt and the stepped pyramids of Mesoamerica share a similar form, but does this shape represent a transferred idea, or is it simply the most logical and stable way for any culture to build towering towards the sky? The universal preference for granite and basalt may not point to a global school of masonry, but to a universal discovery that these are the hardest, most durable materials available. So what does this tell us about ourselves? It reveals a profound truth about human intelligence. Whether through shared connection or isolated brilliance, humanity repeatedly arrived at the same pinnacle of achievement. Our ancestors, separated by continents and millennia, each looked upon a mountain of unshaped rock and saw within it the potential for perfection. Their legacy is not just in the stones they left behind, but in the enduring question of how they did it, a puzzle that continues to pull us across deserts and through jungles in a timeless quest for answers. A single stone at Karnak in France holds its silence, one of thousands standing in eerie, parallel rows that stretch toward the horizon. We can map their positions with satellite precision, yet their purpose remains one of history's most stubborn enigmas. This is the frontier of monolith research, where our greatest tools meet our most profound ignorance. We stand before these structures armed with lasers and supercomputers, yet they continue to guard their core secrets. Who were the actual architects of the Giza pyramids? The official records name pharaohs, but the hands that executed this vision, the master engineers who understood stress vectors and celestial alignment to such an exacting degree, their identities are lost to time. The very quarries themselves are a puzzle. At Baalbek, the so-called stone of the pregnant woman waits in its bed, a block estimated to weigh over 1,000 tons. How did they intend to move it? The earthen ramp theory feels insufficient for such a colossal undertaking, suggesting a method of transportation we have not yet conceived. Even more baffling are the granite boxes deep within the Serapeum of Saqqara. Their airtight precision implies a function beyond a simple resting place, yet their true purpose is never mentioned in any known text. What demanded such an impossible standard of engineering? The symbols carved into the Rongorongo tablets of Easter Island offer a potential key, a written language that no living person can decipher. If we could read it, would it explain how the massive moai were walked across the island, or would it reveal something entirely unexpected about the people's history? Experts in the field openly admit that the central mystery is one of energy. The construction of the Great Pyramid alone represents an energy expenditure that is almost incomprehensible. Where did that power come from? The conventional explanation of tens of thousands of men pulling ropes does not fully account for the speed and accuracy of the work. This has led to more speculative but compelling theories. Could the ancients have harnessed a form of ambient energy, something we are only now beginning to explore? The concept of acoustic levitation, using resonant sound waves to reduce the weight of stone, is no longer pure science fiction, as laboratory experiments demonstrate the principle on a tiny scale. Were certain chambers within the pyramids designed not as tombs, but as resonant generators for such a technology? Other researchers point to the possibility of electromagnetic manipulation, suggesting that the specific crystalline structure of granite could be influenced by focused fields, making the stone easier to move or shape. The peculiar acoustic and magnetic anomalies reported at some ancient sites give these ideas a faint, tantalizing credibility. Yet these theories remain in the realm of speculation, not because they are impossible, but because we lack the physical evidence, the proverbial smoking gun, to prove them. Solving these enigmas will require more than a single breakthrough. It demands a fundamental shift in how we view the capabilities of our ancestors. It calls for a new synthesis of archaeology, physics, and materials science, a willingness to look at the evidence without the constraints of our established timeline. What will it take to finally hear the whisper in the stone? These silent stones scattered across the globe form a single, unanswered question. From the seamless walls of Peru to the granite boxes of Egypt, they are not just monuments, but testaments to a human ingenuity that defies our simple timelines. Our journey has taken us through impossible precision, theories of lost tools, and whispers of forgotten sciences, revealing a past far more complex than we were taught. These structures challenge us to look deeper, to question the established story of human progress, and consider the possibility of a great, forgotten chapter. Perhaps the most important step is the one you take now. Let this exploration be a beginning, not an end. Look at the ancient world with fresh eyes and wonder what other secrets are waiting in plain sight. We would love to hear which theory resonates most with you. Was it the power of sound, the secrets of a softened stone, or something else entirely? Share your thoughts in the comments below. And if you are ready for more journeys into history's greatest puzzles, subscribe to continue the adventure. The stones themselves may be silent, but their secrets are waiting for those who dare to listen.